Welcome to our third section all about optimization of Nmap and running scans with Nmap. There's a number of things you can do to make your experience better, easier on yourself, especially if you have a very large scan. In this video, we're going to talk about ways to reduce your scan time for a large scan. Nmap itself is highly optimized. The author really does a really good job at trying to optimize Nmap to the best of his abilities. But even with that, large scans can really add up when it comes to time. When you're talking tens and hundreds of thousands of IP addresses, it can really take a very long time. One of the first ways to combat this is to prevent unnecessary scans. So if you're trying to find out if things are up, if they're responding, then start out with the ping scan. Run that on some fast system that's deep in the network if possible, and just run nmap-sp and then take that output, put it into a file, and then import it as a list. That way when you go and run the next type of scan, you go a little deeper, such as with an Nmap fast scan, then you only scan those things that are actually up. So speaking of the fast scan, doing that will limit the ports that are scanned. So running nmap-f for the fast scan will scan the top 100 most popular ports. That's a great place to start. You might as well start there if you're starting fresh when it comes to a security assessment of a network. Start at the top 100, then worry about all the thousands of other ports. Hit the big ones first, then follow up with a later scan. It's a common recommendation with a lot of tutorials that are out there to run nmap-a and then whatever your target is. Put in the subnet, call it a day, you're done. That will run everything. That'll run post-processing scripts, all the different tweaks and features that are within Nmap to try and scan and hit everything possible. A is for all. So that is not a great thing to start with. Just start out small, like I said, with -f. Make sure you have your alive host that you want to hit. Just do that to start, then expand your search after that. And you can have that larger scan running while you're analyzing the smaller scan. You can also reduce the time a little bit and reduce the amount of packets you send out to the DNS server by turning off the reverse DNS resolution. Another option you have is to literally make Nmap go faster by optimizing your timing. Now this is a powerful feature that we're going to talk about in an upcoming video where you can actually force Nmap to use different profile levels to run faster by reducing some of the timers. You can also run multiple Nmaps. So you don't just have to have one. When you run Nmap and you define a target subnet and you tell it to do whatever scan flags you want to do, it's going to go consecutively as fast as it can down that list. It's going to hit all those ports. It's going to blast out as many packets as it can for those ports that it needs to scan per device. It's going to go down that list trying to hit every single IP in whatever target that you provided. But it's going to do that with one process. And a lot of times that process is, as I've said, waiting on something. So if you're doing a large TCP scan, that single process may be spending a lot of its time for a lot of those threads that are running for those individual ports. They could be waiting for the TCP to time out, just sitting there twiddling their thumbs. It would be ideal then to have multiple copies of Nmap, multiple instances running, that can be doing that, waiting, all in parallel. A lot of times when you do a scan, even a large one with everything turned on, you are not exceeding the bandwidth capabilities of the interface or the network. Most of the time you're either being CPU throttled or you're waiting on something within the actual processing of the ports. So it would be very advantageous to run 5 or 10 instances, not like 1,000, but just 5 or 10, and break up what you're trying to scan between those different instances. That way, maybe the first Nmap has the first fifth of the subnet that it's scanning, and the second Nmap instance has the second fifth of the subnet that you're scanning, and so on. You can then take those outputs, combine them all into one spreadsheet or whatever it is that you're exporting to, and you can easily utilize those multiple Nmap instances. And the final basic thing you can do to improve your speed is to simply upgrade Nmap. A lot of people don't think about doing that. It might be included in whatever distribution that they're running, and they just go ahead and run Nmap, they don't check it. Check the Nmap version. Make sure that Nmap is running the latest version. For example, I'm on a Raspberry Pi here, which is running Raspbian. Now this is on the very latest of Raspbian, which is Debian based. It is fully updated, and yet Nmap is only at 7.4. The latest version of Nmap right now is 7.7. So even though I'm fully updated on the version of Linux through the repositories that I have access to, I actually have an older version of Nmap. Nmap is continually being developed and continually improved, and the algorithms will change over time to become faster, and tweaks will be included as operating systems change. The abilities of Nmap will change, so always update Nmap. On a system such as this, where I'm a bit restricted in what I can do, you may be able to install Nmap through another means, like say a snap package or a flatpak if those are available, or you can run them as a Docker. So if you have Docker installed on your system, there are actually Docker images out there just for Nmap that'll install just the latest version of Nmap through a Docker container, and then you can run it that way. So there's different ways of getting the latest version of Nmap. You can also download it manually and install it depending on what you're putting it on, but I highly recommend doing that. And even though I mentioned that the bandwidth is almost never a problem, just check and make sure that the bandwidth is not being throttled. Maybe you are on a slow system that just happens to be on a 10 megabit half duplex connection somewhere deep in this ancient part of a network. Take a look and check. Increasing bandwidth or something that might be bottlenecking you down the road may improve your functionality using Nmap. Also check CPU, as I mentioned. CPU can often be fully utilized when running Nmap. There's a lot of things that it's doing, and it actually uses more CPU than it does the network in order to process all these things. So check the CPU on the system that's running Nmap. You may need to upgrade either processing power or bandwidth or combinations of that to get the best functionality of Nmap for your network and your scanning requirements.